Dear students, so let us start our class, from where we left, the last class on determinants. So today we will be discussing the properties of determinants. This is a very important topic, and we will be seeing the application of these properties of these determinants are very important to evaluate the value of a determinant without expanding the determinants. We will see this in due course. So before I start, I would like to confirm from, please confirm that you are able to view the screen properly and you are able to hear my voice very clearly, dear students. Could you please confirm that you are able to hear my voice very clearly and you are able to view the screen properly, dear students? Can someone please confirm? Okay. I got a confirmation our message that yes, you are able to. Anyway, so let us start. The first property says that the value of determinant remains the same if its rows and columns are interchanged. So let me give you an example. So the first property is something like this, the value of the determinant remains the same if its rows and columns are interchanged. If you look into the left-hand side determinant, dear students, what is there? If you look into it in the row-wise, if I read the determinant, it is A1, A2, A3, B1, B2, B3. So it is A1, A2, A3, then B1, B2, B3, then C1, C2, C3. Now, if we interchange the row and column, then what happens? The row, which is A1, A2, A3, becomes the column A1, A2, A3. Correct? The row, what you see is that A1, A2, A3 becomes the column A1, A2, A3. The row B1, B2, B3, that is the second row in the left-hand side determinant, becomes the second column of the right-hand side determinant. And the third row in the left-hand side determinants becomes the third column in the right-hand side determinants. So what we see is that value of these determinants remains the same. So now, remember, if we consider a matrix and after in a square matrix, and after that, if we interchange the row and column, after interchanging the row and column, the matrix what you obtain is known as a transpose of that matrix. So now, what we see from this property is that determinant of a square matrix is equal to the determinant of the transpose of that square matrix. By the way, square matrix is quite obvious. Without square matrix, the value of a determinant is not possible. So here A prime is the transpose of the matrix A. So this is one first property and very important property. So I repeat the property once more, dear students, before proceed for the next property. The value of the determinant remains the same if its rows and columns are interchanged. That means if you interchange the row and column, the value of the determinant remains the same, it is unchanged. And in the other way, what we can say is that determinant of a matrix is equal to the determinant of the transpose of that matrix. Now the second property tells that if any two rows or any two columns of a determinants are interchanged, then the sign of the determinants gets changed. Let me show you this thing and then we'll discuss further. So what is that? If you look into it, if any two rows or columns of a determinants are interchanged, then the sign of the determinant changes. The numerical value, it gets actually negated. So let me show you how it happens. Suppose you see this determinant A1, A2, A3, row wise A1, A2, A3, then B1, B2, B3, then C1, C2, C3. Now what we have done is that we have interchanged the row 1 and row 2. That means whatever there in row 1 becomes the element of the row 2. So if you see the row 1 was A1, A2, A3, that becomes the element in the second row of the right hand side determinant. And B1, B2, B3, which was the second row in the left hand side determinant, becomes the first row in the right hand side determinant. If we do this thing, then what we'll get, the value will be actually negated. That means what? If you get the value of the left hand side determinant is x, after interchanging the row and column, okay, after interchanging any two rows or any two columns, what we'll get the value of the determinant becomes negated. Okay. For example, if we have a determinant something like this, suppose I take a 2 by 2 determinant, 5, 3, 1, 4. Okay. What is the value of this determinant? It is 5 into 4, 20 minus 3. That is equal to 17. Now what I'm doing, dear students, is that I'm interchanging the two rows. That means first row becomes the second row and second row becomes the first row. Then what will be the new determinant? It will be 1, 4, 5, 3. Now if I compute the value of this determinant, that will be 3 minus 20, that is equal to minus 17. And that means nothing but it is minus of 5, 3, 1, 4. That's what has been mentioned, that if we interchange the rows and columns, the value of the determinants gets negated. Now in the same manner, if we do for the columns as well, if you look into the next one, that we kept the same determinant in the left hand side, that is, if I read column wise, it is A1, B1, C1, then A2, B2, C2, then A3, B3, C3. Now what we are doing is that column 2 and column 3 get interchanged. That means whatever the element in the column 3 in the left hand determinant become the element in the second column, and whatever the element in the second column in the left hand determinant become the element in the third column. So then what happened? A3, B3, C3, which is the element in the third column of the left hand side determinant, become the element in the second column in the right hand side determinant. And whatever the second column in the left hand side determinant becomes the element in the third column in the right hand side determinant. Then what we'll see? We'll see the value is actually getting negated because the value is become negative. Correct, dear students? So we learned so far about two properties. Now let's look into the third property. Third property says that if any two rows or columns of a determinant are identical, that means all the corresponding elements are same, then the value of the determinant is 0. So let me give you an example. After that I can show you this thing. Is that suppose we get we have a 4 by 4 determinant, okay, and it has been given and the assignment to us is that we need to find the value of that 4 by 4 determinant. So what is the determinant, dear students? The determinant is something like this. We get 2, 7, 8, 5, 1, 9, 0, minus 3, 2, 7, 8, 2, 1, 9, 0, minus 3. Now, without computing the value of the determinant, you can say the value of the determinant is 0. Why it is 0, dear students? The second row and the fourth row of this determinant are exactly same, right? If you see the second row and fourth row are exactly same. Now as they are exactly same, so I no need to spend time in finding the value of the determinant by expanding with respect to rows or columns. We can directly say the value of the determinant is 0. And it says by means of this statement, dear students, that if any two rows or columns of a determinant are identical, that is, all corresponding elements are same, as we see in second row and fourth row of this determinant, 190 minus 3, 190 minus 3, then the value of the determinant is 0. So in simple terms, if I say, that in a 3 by 3 determinant, is that you can say something like this. Okay, I gave example of a 4 by 4 determinant so that generally to find the value of a 4 by 4 determinant it's little time consuming. But when you see that any two rows or any two columns are identical, then you don't need to spend any time and conclude the value of that determinant is 0. Now it is irrespective of the order. I just gave 4 by 4 because 4 by 4 take long time, relatively longer time than the 3 by 3. But if you look into the two examples what has been given, in the left hand side, you see the row 1 and row 2 are exact. Corresponding elements of the row 1 is equal to the corresponding elements of the row 2. Hence, the value of the determinant is 0. Similarly, if you see the column 1 and column 3, the value of the elements in the column 1 is exactly same of the corresponding values in the column 3. So the value of the determinant is 0. So dear students, so far we have learned three properties. The first property is that the value of the determinant, I'm just recapping so that again we can come back for the new properties. Okay, so far what we have learned, the first one is that the value of the determinant remains the same if its rows and columns are interchanged. So that is the first property. Second property, what we learned, dear students, if any two rows or columns of a determinants are interchanged, then the sign of the determinants changes. Then, dear students, the third property what we learned is that if any two rows or columns of a determinants are identical, that means all corresponding elements are same, then value of the determinant is 0. So these three properties we have learned so far. Now we are going to proceed further. The next point, dear students, is that if each element of a row or a column of a determinant is multiplied by a constant k, then its value is multiplied by k. So let me show you by means of an example and also through the theory. So, let me first write down the point here, dear students, is that as you see here, if each element of a row or a column, if each element of a row or a column of a determinant, if each element of a row or a column of a determinant is multiplied by a constant k, then its value gets multiplied by k. What happened here in this thing? If you see in the row 1, each element of that row 1 is multiplied by k. That means the entire determinant is multiplied by k if you take that k common. Let me give you an example. Okay, so let's take a 2 by 2 determinant because 2 by 2 determinant is take lesser time to compute the value. Suppose we get 2, 5, 1, 7. Now what is the value of this determinant? It is 14 minus 5, that is equal to 9. Now suppose I want to multiply that first row by 3. Then what we are going to get? So we are going to get 3 into 2, 6, 3 into 5 is 15, and 1 and 7 remains the same. So it is 42 minus 15. So it is equal to 27. 27 is nothing but 3 into 9. That is equal to 3 into 2517. So what we see, dear students, now if we see 615, we can write na 3 into 2, 3 into 5, 17, that is equal to 3 into that determinant 2, 5, 17. So this is also a very important property. So if each element of a row or a column of a determinant is multiplied by a constant k, then its value gets multiplied by k. So this is the next property. This is a property what we just learned. Now we can say two important observations here. You can take out any common factor from any one row or any one column of a given determinant. Okay, always you can take that one column, though that is unlikely with a matrix. So let me first write it down, and then let me show you how it actually making sense with an example. So what are the important notes here, dear students, is that if you take out any common factor, so it says that if you take out any common factor from any one row or any one column of a given determinant, which is unlike to the matrix. So let me give an example. Suppose we have a matrix A, and the matrix A, there are, elements are A, B, and C, D, for example. Now, what is the meaning of Ka then? What is the meaning of Ka? As long as the matrix is concerned, dear students, it is each and every element is multiplied by K. If you recall that our matrix classes, if you are not able to recall, you can always go back to my YouTube videos as available in YouTube and the online test platform. Now, what in case of determinant, if we see that what is the determinant, dear students, corresponding to this matrix? So determinant is something like this: A, B, C, D. Now this implies that K into A, if we multiplied that that K into the determinant, okay, then what we are going to get if K into the multiplication of the determinant, it says that you can multiply that K with any row or any column. That means what we can write is that Ka, Kb, but C and D will remain unchanged, which is unlike for the matrix case. Again, we can write that K into determinant of A, you can make it only first column multiplied by K. That means Ka, Kc, but the second column will remain unchanged, Bd. Or you can say, no, I want to multiply that with that K with the second row. Perfectly fine. Then first row will remain unchanged, and second row become Kc and Kd. Or you can say, no, I want to make the first column unchanged, but I want to make the second column multiplied. Absolutely, you can do. So then first column will be AC as it is, and second column should be multiplied by K, that is Kb and Kd. So this is what is actually, that when you multiply a determinant with a with a scalar quantity. And what is K here, dear students? K is a real number. So you can take out, so this is the statement. Now I hope you understand the meaning of this statement. You can take out any common factor from any one row or any one column of a given determinant. And the second statement is also very important. If corresponding elements of any two rows of a determinants are proportional, that is, it is in the same ratio, then the value of the determinant is 0. I want to spend some time on this, and let me use a different color to explain you. This is actually a application of one of the properties of a determinant, along with whatever we just learned, that we can take out any common factor from any one row or any one column of a given determinant. Now to replicate this statement, the second statement, that if corresponding elements of any two rows or columns of a determinant are proportional, that means that is in the same ratio, then the value of the determinant is 0. I want to show you how it becomes 0. So for that, let's take a 3 by 3 determinant, symbolic representation. So it is A11, let me write it down with respect to column wise. A21, A31, then A12, A22, A32, and here I am writing it is K into A11, K into A22, sorry, K into A21, and K into A31. If you look into this determinant, dear students, if you see the first column and third column are proportional, correct? No? Because you see the first column is A11, A21, A31, and third column is KA11, KA21, KA31. That means they are proportional. That means they are in the same ratio. Sorry. As they are in the same ratio, we can say the value of this determinant is 0. But how it is determinant is 0, that I am going to show you. Now, dear students, we just learned from this property. If you see, you can take out any common factor from any row or any one row or any one column of a given determinant. Now what we can do, so as the K is multiplied with each and every element in the third column, so we can take that K out. Then what we'll write? We can write A11, A21, A31, then A12, A22, A32, then A11, A21, A31. Now, dear students, we learned in one property that in a determinant, if any two rows or any two columns are identical, then the value of the determinant is 0. Where we can just go back and we can find it out. One of the property we learned, okay? So if you look into this, if any two rows of a determinant or columns of a determinant, if any two rows or columns of a determinants are identical, that means all corresponding elements are same, then the value of the determinant is 0. So we can just apply this property here. As we see that, column 1 and column 3 are exactly identical. The corresponding elements are same. So using this property, we can write K into 0. That is equal to 0. So now, finally, what we can say, dear students, we can say that if corresponding elements of any two rows or columns of a determinant are proportional, that is in the same ratio, then the value of the determinant is 0. Okay, now let's proceed for the next, property. And that is what is called that, if some or all elements of a row or a column of a determinant are expressed as sum of two or more terms, then the determinant can express as sum of two or more terms, more determinants. Let me repeat that statement. If some or all elements of a row or column of a determinant are expressed as sum of two or more terms, then the determinant can be expressed as sum of two or more determinants. Let me show you, okay, exactly what is meant by that. Just give me a few seconds so that I can bring this in the digital board. So yes, it has come. So if you look into it, dear students, that look into the determinant, the statement I just read out. If you look into this determinant, the first row is expressed as A1 plus lambda 1, A2 plus lambda 2, A3 plus lambda 3, and B1, B2, B3, C1, C2, C3. So this can be expressed as the sum of two determinants. One is A1, A2, A3, B1, B2, B3, C1, C2, C3. And the other one is lambda 1, lambda 2, lambda 3, B1, B2, B3, C1, C2, C3. The second row and third row remains unchanged. As the first row is actually expressed as a sum of two terms in this case, then the determinant can be expressed as sum of two determinants. Now go back to the statement and you will find a clear understanding. If sum or all elements of a row, sum or all, that is also a very important one. Let me give you an example. Suppose, just to understand sum or all, if we get a determinant something like this, 2, 7 plus 5, 7 plus 5, 9 plus 8, 7, 2 minus 3, 1, 8, 0, for example. So in this case, what we see is that it is not all elements of a row is expressed as sum of two terms. If you look into the first row, it is only some terms are actually added. Some terms are not added, some terms are actually expressed as a sum of two terms. So how we can represent this thing? Then also you can write that instead of 2, we can write 2 plus 0, na? Then 7 plus 5, then 9 plus 8, then it is 7, 2 minus 3, 1, 8, 0. So how we are going to express this thing, dear students? We are going to express this determinant as 2, 7, 9, 7, 2 minus 3, 1, 8, 0. And again plus the corresponding elements of the second term, that is 0, 5, let me write 5 properly, 0, 5, 8, 7, 2 minus 3, 1, 8, 0. Now, once our class is done, you can also experiment by your own. You can find the value of this determinant. Then you find the value of this determinant and add to this value of this determinant, you will get the same thing as the whatever is the left-hand side determinant. So that is also a very important property. Now the next one, dear students, is also equally important. That the value of a determinant remains the same if we apply any of the following operations. What are those operations? Is that something like this. If you look into this one, this property is that the value of a determinant remains the same if we apply any of the following operations. If you recall the matrix days, it is as if like that, elementary operations. That Rith row is that Ri plus k into Rj. That means what we are doing is that, the new Ri becomes the old Ri plus some constant multiplied with the corresponding element of the, jth row. Okay, let me show you by means of an example so that you can understand how it is happening. And actually, this is actually happening by means of we can prove it that both the values are same by means of the properties of a determinant. So let's take a determinant something like this. So we take a determinant delta is something like this. Suppose let's take a 2 by 2 determinant, or let's take a 3 by 3 determinant. No problem. 3 by 2 determinants will give you a little bigger view. Is that 2, 5, 7, 8, 9, 3, minus 1, 2, 4, for example. Now, dear students, I am going to find another determinant delta dash. Okay. What is the value delta dash? Or just not to confuse with delta dash, suppose this is delta 1. And I'm going to find another determinant delta 2, which is something like, just make your operation something like this. that, R2, the R2 becomes, 2 into R2. I'm sorry, it is R2 equals to R2 plus 2 into R3. If we do this thing, then first and third row will remain the same, 2, 5, 7. And third row also you can write like this, -1, 2, 4. That is remain the same. What is our new R2? Our new R2 becomes, what is the old R2? That is 8 plus 2 into R3. What is the corresponding element of R3? 2 into -1. Then let me do one thing. Let me write in a little bigger manner. Okay, just give me a minute. Let me write it in, so that you get the essence that how come these two values of the determinants remain same. So what is the delta 2 we are going to get, dear students? Is that it is a determinant. What I'm going to find it out here. Under what operation? That R2 is R2 plus 2 into R3. And how we are going to get it? So R1 and R3 remains the same. So that is 2, 5, 7, 2, 5, 7, and -1, 2, 4. This first and third row remains same. What is the new second row, dear students? It is the old element 8 plus 2 into corresponding element of R3, that is -1. Similarly, here you will get what? 9 plus 2 into 2. And then what we get? 3 plus 2 into 4. Now, according to this statement, what you see here, dear students, the value of delta 1 is equal to the value of delta 2. Right? Now, how the value of delta 2 is equal to value of delta 1, I want to show you. Now, dear students, the moment we get delta 2 like this, we just learned that we can express this delta 2 as a sum of two determinants, because each and every element of the second row is actually expressed as sum of two terms. So what we can write here is that, dear students, we can write 2, 5, 7, 8, 9, 3, -1, 2, 4, plus 2, 5, 7, 2 into -1, 2 into 2, 2 into 4, -1, 2, 4. Using the property we just learned, that each and every element, if some or all elements of a row or column is expressed as a sum of two terms, then the determinant can be expressed as a sum of two or more determinants. Now, what we're going to get it here, dear students? So if you look into it, that this determinant, right hand side, the first determinant in the right hand side is nothing but delta 1. So we get what? Delta 2 is equal to delta 1 plus. From this determinant, dear students, what we can do is that we can take 2 common. Why? Because the element 2, not element 2, that real number 2, the scalar quantity 2 is actually multiplied with each and every element of the second row. And using the property of that determinant, what we can see is that we can take that 2 out. If we take 2 out, what we get? 2, 5, 7, -1, 2, 4, and -1, 2, 4. Now, dear students, we learned one property today, that if any two rows or any two columns elements are identical, that means the corresponding elements are same, then the value of the determinant is 0. So what we see here, dear students, the element in the second row is exactly same as the element in the third row. So the value of the determinant is 0. So what we are getting out of it? So from here, we get delta 2 is equal to delta 1 plus 2 into 0. That implies what, dear students? That delta 2 is equal to delta 1. And hence the proof, whatever we have learned, is that whatever we have actually claimed, that the value of a determinant remains unchanged or remains the same if we apply any of the following operations. That is, Ri is equal to Ri plus KRJ, or Ci is equal to Ci plus LCJ, where K and L are some constant, real number. Now, dear students, these are the properties are extremely important. Every year there are questions, coming in the entrance examination that find the value of the determinant without expanding it. When to find the value of the determinant without expanding it, all you need to do is that make use of these properties what we have learned today. Okay, and let us solve a couple of problems together just to understand how efficient usage of all these properties can help us to find the value of a determinant efficiently and in a very time efficient manner. That means it will not take much time. So those examples I'm going to do in the next page. Okay, so let me first find a this is the problem. Show that the question is something like this. And I will suggest you, dear students, you also open your notebook. You also do along with me. That so that delta, that is equal to, it is a 3 by 3 determinant. So determinant of order 3. I read row wise. It is 1, 1, 1, ABC, and A square minus BC, B square minus CA, C square minus AB is equal to 0. That we need to prove. Or the other way the question can be given, that find the value of this determinant, whatever you see delta. So how to find it out? So what is delta, dear students? So delta is equal to, I just want to do it slowly so that you can make use of the properties very efficiently. 1, 1, 1. It is A, B, C. Now A square minus BC, B square minus CA, and C square minus AB. This is the determinant. Now what comes to our mind is that, so what we are going to do is that I want to subtract the second column from the first column. I want to subtract second column from the first, okay, and the third column from the second. If we do, what we are going to get it? Let's see. So after doing this operation, what we are going to do is that, here our operation is that our column 1, okay, is column 1 minus column 2. Okay, if I do column 1 is equal to column 1 minus column 2, what we are going to get? So this is equal to, what operation I'm going to write? I'm going to write the operation column 1 is column 1 minus column 2. Okay, by the way, let me tell you, both are of the, same meaning. Column 1, new column 1 is equal to column 1 minus column 2. In some books written in the first manner, first the way I wrote, and some other books also written this way, but both are the same thing. Then it is 1 minus 1 is 0, then A minus B, and A square minus B square, correct, na? Then plus CA minus BC. plus CA minus BC, that means you can take C common and you get A minus B. Let me do one thing, dear students. Actually, I need to write in a bigger manner so that you're able to get it very clearly. Just so what I wanted to mean is that the first column is become the first column becomes the new first column becomes the old first column minus column 2. And as I was telling, dear students, that this statement is equivalent to the statement that C1 is arrow is on the right hand side, C1 minus C2. In some book it is written in this way, and some other books it is written this way. So what will happen? It is 0, then A minus B, then A square minus B square plus C into A minus B. Then the remaining columns remains same, that is 1 B square minus CA, 1 C square minus AB. Correct, dear students? After that, what I'm going to do, dear students, is that I want to make the new second column is the old second column minus the column 3. Correct? So then what we are going to do is that, so if I'm going to make this operation, so it should be something like this: 0 A minus B, we get A square minus B square, A square minus B square plus C into A minus B. Then as we are doing the operation, that C2 is C2 minus C3, what we are going to get? 1 minus 1 is 0. B minus C, it will be like this, and then B square minus C square, correct, plus A into B minus C. Correct, dear students? And then 1 C square minus AB. So we make this thing. After that, what we are doing, if you look into the minutely, if you look into the third row, you will find what? That you can take A minus B, you can take common from the first column, and B minus C you can take common from the second column. So then what we are going to get? You are going to get A minus B, you are taking common, and then B minus C you are taking common. Then if I read it out in the write it out in the column wise manner, 0 1, it is A plus B plus C. Correct, dear students? Then 0 1 A plus B plus C, and 1 C square minus AB. Correct? Now, if someone of you is not able to understand that how it becomes A plus B plus C, I can help you by just calculating it one terms. Just take out of this thing. Just let's concentrate on this thing. So what we are going to get, let me compute it here. So this is equal to what? A square minus B square is equal to A plus B into A minus B plus C into A minus B. Now from these two you can take A minus B common. The moment you take A minus B common, left with is that A plus B plus C. Now that A minus B is also there in this element in the second row first column. So altogether you can take A minus B common. So you left with 0 1 and A plus B plus C. And same thing is true for the second column. Now dear students, if you look into it, that what we see, the elements in the first column are exactly same as the element of the second column. Now we learned one property today. If the corresponding element of any two rows or any two columns are identical, that means the corresponding elements are same, then the value of the determinant is 0. So then what we'll end up with? We'll end up with this is equal to A minus B into B minus C into 0. That is equal to 0. So dear students, I did it slowly, but you can do it fast also because you are learning. That's why you should learn slowly so that each and everything is very clearly understood. So that you see, but if you start finding the value of the determinant by expanding with respect to any row or any column, it will take relatively longer time. And sometimes there are questions where it has been mentioned so that delta equal to this without expanding the determinant. That means you need to use the properties of the determinant to establish that. So now you understood, dear students, the value of these properties, whatever we started learning today. Now let's solve another problem together. Suppose this is the next question. So question here is that so that the value of the determinant delta, that is equal to, if I read row wise, it is B plus C, C, B, C, C plus A, B, A, B plus A. That we need to show that it is equal to 4ABC. Now, how to proceed with this one? What comes to our mind when this kind of determinant, what is seen the, it is there. So you need to just look through it, that how you can find a pattern to take something common or something like this. Now, if I look into this determinant very minutely, if I make that my new row R1 is equal to R1 plus R2 plus R3, then what will happen, dear students? If you look into the first column elements is actually get added, so it becomes, 2b into b plus c plus b plus c. Correct, na? So what I'm saying is that let's look into this determinant, dear students. The delta is equal to, let me write it down. Let me do slowly. No hurry, because this pattern understanding is very, very important. B plus C, C, B, C, C plus A, B, A, B plus A. By looking into, first you need to spend a minute that what kind of pattern I can find it out. What I see, dear students, you see, if I use a different color, that B and C is there, which I can club it here. C and A is there, what I can club it here. A and B plus A is there, which I can club it here. And after that, what we'll get? In the first row, elements will be 2 into B plus C plus 2 into B plus C, then 2 into C plus A, then 2 into A plus B. As I'm finding this pattern, so I need to use it. So what is the property I'm going to use it, dear students? So I'm going to use the property that, let me use a different color. So the property what I'm going to use here is that my new R1 is equal to old R1 plus old R2 plus old R3. If you recall that, that elementary operations on matrix, as long as the elementary operation, the way you perform the elementary operation on matrix, it is similar to that. Whenever we do this kind of, algebraic operations on the elements on the determinants. So then what we get here, dear students, B plus C plus C plus B. That means 2 into B plus C. Similarly, we get 2 into C plus A. Then we get 2 into A plus B. After that, what we get, dear students, C plus A, B, A, B plus A. Correct? So after that, what we are going to do? After that, just a minute. We can take 2 common, because as we learned that if one element is multiplied with any row or any column, we can take that element common. Here what we see, the element 2 is multiplied with each and every element in the first row. So we can take 2 common. The moment we take 2 common, what we get is that B plus C, C plus A plus B, then C, C plus A, B, A, B plus A. Correct? Now after that, what we can do? Let us think together. Is that if you look into it, we can do that. What comes to my mind is that we can do R2 is equal to R2 minus R1. Okay. If we do R2 is equal to R2 minus R1 and R3 is equal to R3 minus R1, what we are going to get, dear students? So the next operation what I am going to perform is something like this. This is equal to 2. What I am going to do is that R2, I am just writing the operation here. New R2 is actually R2 minus R1, and R3, new R3 is actually R3 minus R1. These operations I am going to do. So the first row remains the same, that is B plus C, C plus A, and A plus B. Now R2 is R2 minus R1, so C minus B minus C, that becomes minus B. C plus A minus C minus C, that becomes 0. A minus C minus B, that becomes minus B. And similarly, what we get, B minus C, that becomes minus C. A minus C minus C, that becomes minus C. And then B plus A minus B, that becomes 0. Now we come to a very comfortable position now. After that, what we can do, we can expand this determinant with respect to a row which has zeros. For example, we can expand this determinant with respect to the third row. If we expand the determinant with respect to the third row, so this expansion is justifiable at the end. After doing I said, otherwise you'll find that, sir, it is contradicting to your statement that you are not supposed to expand. You are, because once you come to a very considerable position, okay, means very easy, the determinant is easy where we have zeros. So if we expand with respect to the third row, what we are going to get is that it is minus C, and then the determinant should be C plus A plus B, 0 minus B, then plus C. What we are going to get is that B plus C, A plus B, minus B, minus B. Correct, na? So this we can write. Now from here, what we can take common, we can take 2 into minus C common. Okay. So what I'm saying is that this is equal to 2 into, let me write it down so that, you will get that idea, minus C. So what we get, C plus A plus B, 0 minus B, and that minus B we are taking it common. So minus C into B, what we get? B plus C, A plus B, 1 and 1. Correct, na? Then what we are doing, dear students, minus 2C I am taking common. Then after that, what we are going to get? It is minus B into C plus A, expanding the determinant 2 by 2, and then 0. And then what we get? Minus CB into B plus C minus A minus B. Correct, dear students? So what we are going to get it here then? Minus 2C. I can take the B common out also. From here we can take B common. In fact, minus B common. Then it becomes plus 2 into C into B. Then what we are going to get it here is that C plus A, and then when we took that minus C common, then this C should not be there. This C should not be there. It should be only B. Okay. So now as we took that minus B common also, so then we'll end up with here B plus C minus A minus B. So in fact, first bracket is sufficient. So then what we get is that A and minus A and A got cancelled, plus B minus B got cancelled. So we'll end up with, here it is BC. Just a minute. What we did is that minus B took common, C plus A, B plus C minus A minus B. So let me look into this sum once more. Let me look into it where I made any mistake here or not. So I am expanding with respect to the third row. Plus minus C, C plus A plus B, 0 minus B, plus C. Then we get B plus C, A plus B, minus B minus B. Then we took minus B common, and here as it is, we took minus B common. Then we get what? B plus C, A plus B, 1, 1. Then from these two we took, minus C common. Acha. The moment we took minus C common, then here, dear students, the moment I took minus C common, then this should be plus. Correct? The moment this should be plus, so what we can do is that, after that, so last step, there is a mistake happened. So what I'm going to do is that, let it be there, and then from there I just take, the B common, then minus 2BC, then what we get? Minus C minus A, okay, and then plus B plus C minus A minus B. Now what we get? C is cancelled with C, B cancelled with minus B. So what we'll end up with? Minus 2A. So minus 2BC into minus 2A. So that if we multiply, then we get 4ABC. And we are able to prove it, dear students. So just by applying the properties of the determinants. Now, you may have a very fundamental question. You can ask, sir, is it the only properties what you are doing, that is the only properties I need to use? No. You can use properties in your own way. But your target should be that you are towards the result. That means either you bring maximum number of zeros in the determinants, okay, or you transform the matrix in such a manner by means of this, using these properties, that it becomes very efficient to calculate the value of the determinant. Your thought process will be like that. But what about the properties I have used? It doesn't mean that you need to use the exact properties. No, not like that. So now, dear students, you know, we can solve one problem together. Okay. Um, let's solve one problem together. Okay. That should be the last question, and let's see that how efficiently we can do this thing. Okay. And this kind of problems are very likely to come in the entrance examinations and also to some extent in your board examinations as well. That is the question number 3. So what has been given here, dear students, that we need to prove the value of the left hand side determinant is equal to the value of the right hand side determinant. So now how I can proceed? I would like to proceed from the right hand side determinant. Okay. How? So right hand side determinant, so I can write RHS is equal to 1 BC B plus C, 1 CA C plus A, 1 AB A plus B. That is the right hand side determinant. But what I'm going to do, dear students, here is that as I see in the left hand side, I have 1 1 1. You see, you need to think about that. Your target is to bring it to the left hand side determinant. So 1 1 1 is there, so that is good. ABC is there, A square B square C square is there. How to bring this one? So for that, one thing comes to my mind is that let's make the third column in little different manner. So first column remains the same, 1 1 1. It is BC CA AB, and in the third column I'm writing A plus B plus C minus A plus B plus C minus B, A plus B plus C minus C. I hope all of you agree to me, dear students. Instead of B plus C, whatever is there, instead of this B plus C, what I wrote, dear students, is that I just write it as A plus B plus C minus A. Okay. Otherwise, it is same. But the moment I have done this thing, I got something very interesting. What is the interesting thing? If you recall, if some elements, either row or column, is expressed as a sum of two terms, then you can express the determinant as the sum of two different determinants. So that means what I can do is that I can write this thing is equal to so what I can do, this thing is equal to, it is 1 1 1 BC CA AB A plus B plus C A plus B plus C A plus B plus C, and then minus, what we can write is that 1 1 1 BC CA AB A B C. Correct, not your students? Now what happened is that if you look into this, in the right hand side there are two determinants, this and this. Now this determinant is actually 0. Why you know? Because you can take A plus B plus C common from the third column. After that, what will happen? You left with the third column as 1, 1, 1. That means what? Let me do it. So, but in your entrance exam, you don't need to do all this step by step. In board examination, it is required, but in entrance examination, it is not at all required. So we can take A plus B plus C common from the third column of the first determinant. Then what we get? 1, 1, 1. Then BC, CA, AB. Then 1, 1, 1. Now, in the second determinant, what I am doing, dear students, is that I want to interchange the first column and second column. Why I want to do so? Because if you look into the left-hand side, if you look into the left-hand side, a determinant, it is in the first row. Is that first row? What we see is that is equal to 1, 1, 1. So what I want to do is that I want to interchange the first and second column. And if you recall, dear students, if we interchange any two rows or any two columns, the value of the determinant become negated. So this minus become plus. And what we are doing here, it is BC, CA, AB, 1, 1, 1, A, B, C. Now, dear students, what we will end up with, if you look into it, in the left-hand side, in the right-hand side, this determinant is 0 now because the first column and third column are exactly same. So we can write A plus B plus C into 0. Now, what we get in the right-hand, in the other determinant is that it is BC, CA, AB, 1, 1, 1, ABC. That is the column-wise order I read. So what I'm going to do here, dear students, is that I just want to take 1 by ABC common from the first column. If I take 1 by ABC common from the first column, then what I'm going to do is that if I write 1 ABC, then what I'm doing is that I'm multiplying. So let me write it down properly. So here it becomes BC 1A, CA 1B, and AB 1C. Now, if we look into this thing, dear students, is that what we are going to get is here is that it is simple matrix. What we get, a simple determinant we get is that BC 1A, CA 1B, AB 1C. But what we need to prove? We need to prove is that, that if you look into the determinant, ABC will be the second column elements, and A square, B square, C square should be the third column element. So to do this thing, I need to multiply the first row by A, second row by B, and third row by C. So then what will happen here? If I multiply first row by A, what I'm going to get? A, B, C, A square. So then I need to divide it by A. Correct, no? Then second row I'm multiplying by B. So what I will get? ABC, B, B square. So I should divide by B to adjust it. Then the third row I'm multiplying by C. So it becomes ABC, C, C square. Correct, not dear students? After that, what I will do, so to make it adjustment, I need to divide by C. So then what we get? I want to take ABC common from the first column. If we take ABC common from the first column, so what we'll get? ABC divided by ABC. What we're getting? Column wise, if I read 1, 1, 1, A, B, C, A square, B square, C square. Now ABC by ABC is nothing but 1. So we land up with 1A square, 1B B square, 1C C square. Since ABC is not equal to 0, which is quite obvious, and that is nothing but the left hand side determinant. So dear students, I took time, I explained slowly so that you understand each and every process. After this class, I will share with you the entire video lecture over YouTube so that you can again follow it up. That will be available to you in another 1 hour from now. So with this, if you proceed, and make more practice, so you will find that, the problems are becoming very, very easy. You will be able to, solve problems, with very efficiently. And dear students, for practicing, I will always recommend, go to the website, as you know, that for efficient way of practicing, to get the study material, the mock test paper, the unit test paper, practice test paper, so go to www.KonarClasses.com, go to the website www.KonarClasses.com and look for video lectures. All these video lectures are available there, whatever I am delivering and some other faculties video lectures. Then appear for what is that? DPP, that is called daily practice problems. Then you appear for PTs, that is known as practice tests. Then appear for UTs. UT stands for sorry, UT stands for unit tests. Then you can appear for MDTs, that is called module tests. And then finally appear for MTs, that is stands for mock tests. After doing all these things, one thing is assured, that a great rank for your engineering entrance examination is in your hand. That is for sure, that I can assure you. With this, dear students, I would like to conclude the class for today. Thank you very much, and we will have our class a day after tomorrow, and there we will discuss something very interesting about the determinants and the solution to the system of linear equations. Thank you very much, dear students. Take care.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you very much.